Glad to have you here, and we have an esteemed panel here. We'll talk about some of the innovations with analytics and governance that these leaders have enabled at their companies. So to introductions, I'm Shikha Verma. I'm the head of product for data and AI governance at AWS. And I'll hand it over to my panelists to introduce themselves. Mirka?
Mirka Walter, VP of Engineering at Natera. And I've been working with AWS for a long, long time. Still remember when reInvent was actually just in the Venetian. So that was back in the days. Fun fact, I really love action sports, so you might see me somewhere on the snow or in the air. So hand it over to Zach.
Hi, I'm Zach Anderson. I'm the Chief Data and Analytics Officer at NatWest. I've been working with AWS through multiple companies for many, many years now. I guess the fun fact I like is before I came to the bank, I worked for a video game company, and I was Electronic Arts, and I was part of the creation of one of the most downvoted posts in Reddit history. Almost 10 million downvotes, which is I don't know if it was fun. It certainly wasn't fun at the time, but in retrospect, it was an interesting time. So.
Hey, thanks, Zach. Hi, folks. My name is Shiva. I'm with Amazon. I am one of those guys behind the scenes that builds these systems that helps deliver the packages on time. And I've been working with AWS for a long time, with Infosys, where I was a CTO, then later with a hospital, and then as a startup guy, and now obviously with Amazon. And have used SageMaker extensively in the past. We ran deep learning for routing, which was novel, and now we are using the entire SageMaker platform. Fun fact about me, I'm a big rock music fan and a much bigger Led Zeppelin fan, and surprise, I bumped into Robert Plant last year, and I have a picture to prove it.
Cool. Well, I'm so happy for you guys to join us on stage here to share your stories. Let's get started. Who here has not heard of generative AI? Is there anybody who's not heard of generative AI, or it isn't shaking their world up right now? No, nobody, right? It is the theme of the era, and it's powering innovation that is really transforming businesses across the world. So that's what we'll focus on in the beginning with our panel, on just how is their world changing with generative AI, and what are we as AWS doing to enable that as well. So you showed up here for an analytics and governance session, so I'm assuming you're data people. Anybody here claiming to be data people? Yeah,
Me.
Some of you. Okay, cool. Good. I'm definitely data people, so I like that. And your data is your differentiator for generative AI applications, right? Because what you can get generically without customizing your models with your data is generic outcomes. When you really, that's really the tip of the iceberg, right? The value of the generative AI systems comes through the data that you use to train your models and generate outcomes that are tailored to your business. And customers are investing more and more in being data-driven, right? We have CDOs, VPs, directors sitting here. Their companies are investing a ton. And more companies are appointing CDOs. Zach, you have a lot more partners in crime now across the world.
When I started as a chief data officer, there weren't very many in the world. Now seems like tons.
Yeah, it's right. And for our research, 82% of organizations have appointed CDOs or CDAOs now. 94% have invested more in 2023 and 2024. 20% are seeing more revenue growth because 74% of businesses still fail in becoming data-driven. These leaders know a thing or two about data, and I'm sure you guys as well. That's why you're here. So that's some of the things that we will talk about in today's session, is what are their learnings, how have they enabled that. Anybody here who can say that, yes, our company is very data-driven? Anybody? Very few companies can still say that, so I appreciate it. Oh, yay, there's a group there that is very data-driven. Awesome, would love to hear from you during a Q&A and share some stories.
Bizarrely, one of the things that goes along with those facts is the average tenure of a CDO and a CDAO is only about 2 years.
Yep.
That's
Which
right.
is kind of crazy also when you think about it, even shorter than a CEO or a CMO.
Yeah.
And it's partially because 74% of them are failing to do what they were hired to do. So.
That's right. That's right. Because the problems we run into are these problems, right?
Yep.
Like the huge data sprawl and the huge tool sprawl that we have in our worlds. Most times it cannot be solved in a couple of years. These are long-time journeys. You have to embark on multi-year initiatives. Thank God we have this cool thing as generative AI in our back pockets now, which we can apply to go a little faster. So I'm very excited to get into some of the use cases that our panelists have to share. But do these challenges look familiar to you guys? Like, show of hands, does this seem familiar? Are you dealing with lots of data, lots of types of data, a lot of tools? Yeah, seems like it. Okay, cool. So let's get into our first question. So here we have, 3 industry experts. Mirko from Natera represents healthcare life sciences. We have Zach representing financial services, and we have Shiva representing large logistics, Amazon transportation. Like the scale of that is just monumental. So I'd love to hear from you guys on how the world of data analytics, ML in your companies and in your industry is changing with generative AI. So Mirko, if we could start with you.
Sure. So Natera is basically a clinical testing lab. So we're doing many, many tests. We just recently passed 10 million tests here in the US, where we're doing sample acquisition, DNA sequencing, interpretation, and then reporting to our patients. A key aspect there is in our space as well, not just the genetic data and the results that we're getting out of it, but also being able to actually use clinical data. And combining those two is kind of like a dream from a lot of healthcare companies out there, being able to do that in a coherent and fast way. In the past, we have done this, but it was really hard to kind of do that manually. You had like bunches of people going through unstructured data, bunches of people trying to kind of make sense out of those EMR records, out of those progress notes, and so on, and being able to actually extract the information that we want to be able to combine that. On the Gen AI side now, since about 2 years, we really had the opportunity to do that in a way bigger scale. Until now, as mentioned, we had teams doing this manually, but now with Gen AI, we're actually able to leverage the LLMs to go through the vast material and text that is available in those different unstructured data sources. So if we're looking at those data sources, we are getting like path reports or progress notes through our accessioning. So whenever a physician is ordering a test with us, we get patient clinical information sent over, and then also have the ability to basically tap into EMRs or other digital channels to get additional clinical information. The ability now to use this, actually archive those documents and extract the text out of it was already there before. So that's not something new. You could OCR the actual documents or basically extract the information directly. But what we're now able to do is take that information and store it in our vector store that we're using together with our LLMs. So the vector stores allow us now to find semantically in the information of the clinical patient of what we actually want to extract. So one piece that we're kind of looking at is things like medications that patients had, treatments that patients had, or surgeries, corresponding dates. So creating a whole history of a patient and being able to actually show that journey of those patients together with the actual lab results. So that's kind of like the workload we can run on top of it, which allows us now to, with simple prompts, to basically extract exactly those clinical attributes being able to validate those, obviously. Most of it can be done through the LLM as well. So using an LLM as a judge, for example, being able to look at the data, extracting and seeing if the data is valid. But some of them might be human in the loop. So we basically escalate that and make sure that the data is correct and can then push it into our data mesh. So from there, we basically now have a digital health record of the patient that was using our test. And particularly, one very nice example where we can apply this is in one of our tests, which is monitoring the cancer treatment of a particular patient. So what we're seeing here right now is a stage 2 bladder cancer patient with the full cancer journey that we were able to extract on one end from the clinical data that we're getting from the patient, but then also leveraging our test data that we're running in our labs. What we're seeing here on the screen is like a patient which first had a non-invasive procedure with like a neoadjuvant chemotherapy as well. So those are kind of the first data points you see on that line. At day 181, the physician basically decided to a surgery and get the tumor out, which we then used the tumor to kind of create a fingerprint of that tumor sample, and are now able to figure out over time how many cells we still find in that patient during the treatment that is going on. So as you can see, kind of like in those first 3 data points, our test was negative, so which means that the treatment actually worked. But as you can see on 0.456, the actual test moved into positive, which means that something is going on in that patient. And with that, the physician knew that there might be a distant recurrence that he then confirmed on day 573. So from there, the physician applied radiation and then another IO therapy treatment. And as you can see at the end of it, the test basically moved into the negative space again. So being able to create those journeys that you see now, combining test data and clinical data, is now enabled through Gen AI and LLMs that we can do for every single patient that goes through our lab. We wouldn't be able to do that before. We could do that on a small cohort of patients. Now we can do that on every patient. And I think this kind of like shows us how applicable this is, not just from a business standpoint, but also from a healthcare standpoint and from a treatment standpoint. So the other thing we can do now, obviously, is taking all those patient journeys and combine them. So what you're seeing here on the screen right now is every horizontal line basically represents a patient journey. We have a bunch of patients now here on the screen where we can see the actual test results, we can see the procedures that have been applied, we can see the therapies, and then also the outcomes. This allows a physician to now compare patients which are similar to the patient that they're treating right now, and also allows them to like have treatment timelines mapped out for their patients, or also think about new strategies they can apply to a patient when they're working, and can compare them to different other patients that they have in their clinic. So this is a small example of where we're basically extracting unstructured data out of clinical records that we're receiving, and can now apply that in a very coherent way across all the patients that are going through our lab.
That's a pretty interesting example. Anybody from healthcare here? Does this example resonate? Looks like we have some. Great. Be great to talk to you more during Q&A. All right, let's see what financial services is dealing with, and what Zach is up to with Chat with Data.
Yeah, I think some of the most interesting things about the generative AI space for us has been frankly, the shift in who's engaged. I would say most of my career, data scientists have had to provoke and inspire business people to care about a machine learning model or what the technology can do. And what's happened with generative AI is we now have, councils across all of our business units that give us hundreds of ideas each around the way that we can use AI in their businesses. And it's really flipped the paradigm. As a leader, it's pretty difficult now. We used to be able to kind of manage our resources really easily. Now, still tough, but now it's how do we keep up with what the businesses want? And that's enabled us, that shift, I think, has really been powerful for us in the way that we're thinking about deploying generative AI inside the bank. So we really think about it now as like how can we build crowd tools that we can deploy out using SageMaker and applications that many of the bank's technology teams can deploy. And then secondarily, how do we think about the long term, what's going to be possible, and start to build those use cases with our core data science teams. And I'll give you 2 examples of this. So in the provoke and inspire space, we've been doing call summarization for our Coots customers, which is a private bank that we own, for our relationship managers. So when they have a call with a customer, it's really sensitive data, so we have to hold it all internally. And so we've been doing normal NLP and then BERT models to do that for a long time. And getting better and better at it, and it was a pretty good tool set. But we really had to inspire the business to even really care about it. And now they've totally adopted it. Obviously, the implementing LLMs in those use cases has made it much, much better and much stronger. And what they're pulling us for is now all right, you can help me in the meeting, but how do you help me before the meeting? I have to do all this information gathering about my customer across all their records in the bank that might hold multiple accounts. We're a big corporate bank too, so a lot of the Coots customers also happen to be an investor or an executive in one of the corporations that we bank, and so they need to pull all this information to be able to really understand each customer. And we've been able to deploy actually really similarly to your use case, the extraction of data from many systems across the bank, summarization of that, extraction of key facts that gives the relationship managers everything they need to go into the meeting. And it's just amazing to me because the feature list backlog now of that tool is huge, whereas we could barely get them to use the call summarization before. And so that shift, I think, has been really interesting. Similarly, we have another set of use cases that has been demanded by our fraud team. So we probably have been building fraud models with machine learning because it's such a great categorization tool set for just doing is this fraud, is it not, how do we stop a payment for a really long time. But actually the team that has come to us recently is the fraud investigations team. So when it's a really complex fraud, we think there might be multiple people with accounts across our bank and other banks, what we would call first-party fraud, that have a network of moving money around and money laundering, often human trafficking. And we were able to build a graph embeddings model across all of our accounts and actually what we would call third-party, which are accounts held outside the bank that we send money to, that allows the fraud investigators to do really incredible fraud investigations and see the networks of how money moves between accounts, but also IP addresses, home addresses aligned, names that are similar, all these kind of soft facts around all the accounts, and they can use the network graph that we have to traverse that. And then what's been amazing is the addition of LLMs, both to extract entities and elements to feed that graph from our existing systems, but also to then crawl that graph and be able to provide a new way for the fraud investigators to be able to investigate it. And we've had some pretty incredible things. So we are now discovering fraud networks and the depth of them much, much faster, something like 10 times faster. So it used to take an investigator weeks to do, now it takes them a couple of days. We just had a pretty important case that we saw where we were able to find a fraud network inside of our bank that included one of our customers. That customer ended up to be a person that had been human trafficked from Eastern Europe into Ireland. We were able to turn over a very complete file to the police force that then shut down that fraud, freed that person, got her out of the sex trade, and make arrests around that. And their claim was that they had never seen as much information available on an investigation because no other bank has ever provided that set of information. And we were able to show them accounts in other banks that really enabled them to prosecute the individuals, which was pretty incredible. So really interesting cases, and that frankly would have never happened. We've implemented lots of categorization models in machine learning models in the fraud space, but it was the investigators that came to us after thinking about what can Gen AI do that enabled us to build that with them and then create a really new set of deliveries that had real impact on people's lives.
Amazing. Who else is struggling with fraud analysis here? Anybody else? No? All right. I'm sure others will find value out of it. But I found that fascinating. With all the data that you have to churn through to actually get to that quickly, it's pretty amazing.
Yeah,
all right.
I think there's incredible use cases. So in Amazon, see, from the time that you actually go and select something out of millions and millions of ASINs that are in the long tail that we sell, to the time that it actually gets delivered to what we call promise, when it says expected by this date, it's a very finely balanced choreography at massive, massive scale. And what my team does is, it's one of those teams which works behind the scenes and gets all the information in order and gets insight so that we actually meet the promise, which to us is super, super important because we are a very customer-obsessed company. So just some data facts about, if you could go to the next slide, just some numbers, what we do. To be able to deliver the billions of packages that we deliver, every year, we have petabytes of data being generated every day, structured, unstructured, all over the place. And we have 50,000 different active admin kind of users, power users, analyzing all this information. We have more than 100 different systems. We have like 50,000 users, 40,000 metrics that they track. And so it's a very complex problem. And there are different systems which are the sources of truth. And as you would expect, any kind of metadata management, master data management system, you have all these silos, duplications and stuff. And you have to make sense of all this mass of data, petabytes of it every day, and come to those kernels of insight which help prevent a miss. We want to get our packages to the customers on time. So that's really this scope and scale of this problem. And this is global. So what we did is we chose one specific problem, which is, that's the one I'm going to talk about today. It's at the delivery station. This is the last mile. So when the packages have gone through first mile, they've gone through line haul, now they are at the delivery station. They'll get into these vans, these ubiquitous vans that you see that deliver stuff to your home. So we are a very planning-focused company. Like for every day, we have plans. These many packages, these are the routes, these are the vans, and all of that. So these are the plans we have. And every day, we have actuals. We planned something, and some things didn't work out. So now what happens is there are people on the floor who are evaluating the plan, looking at all this information, and saying, OK, what went wrong? Doing root cause analysis. And this is happening at every station, and then it gets merged into a region, it gets merged into a director level and ultimately a VP, and they're looking at the network holistically and saying, okay, what is happening? Where can we put our resources so that we can improve the overall health of the system? Very, very intensive, very human intensive work, like 15 to 20,000 hours spent every day doing this analysis. So we said, let's tackle that problem first. And To tackle that problem, first of all, you have a cold start problem. Like you don't have this root cause analysis. There is a huge amount of data, and the root cause graph could be n levels deep. It could be very wide. So you have to start first with a knowledge graph. So we started with an expert system-based knowledge graph. So that is where we started with machine learning to solve the cold start problem, leveraging the wisdom of the people who have actually been doing this. And then we had these models which would learn and expand, because a human being is only capable of seeing what they know, and they typically fall back to their historical patterns. To build on top of that, then we had these machine learning algorithms, different types of algorithms, but what they would do is cast a wide net and look at other patterns, try to find correlation, and then see if they are part of the knowledge graph, and then have a closed feedback loop and do some experiments and figure out if they should be if they should be part of the whole root cause analysis. Now, once we have that done, then we ran some pilots, and then we generated these insights that people write through LLMs. So what we did is really what is called Composite AI. We used machine learning to do the root cause analysis, and then we used Gen AI to represent that to the station level. And this is what we rolled out in all of North America and Europe. So we rolled it out in all of North America, Europe, 91% acceptance. So people, they're looking at that and saying, wow, this is great. This is what I would do. And in some cases, they're saying, this is even more than what I would do. You found correlations that I didn't even know exist. What we're going to do next is we're not going to use LLMs to do some of the reasoning itself. We didn't start with reasoning because the technology wasn't there. Now we're going to use LLM-based reasoning, and obviously we'll be using GANs to challenge reasoning and make sure that it is accurate and so on. So that's one aspect that we started working on for next year. The other thing that we're going to do is we're going to focus on agentic AI. So we have these actionable insights. The people on the floor, they seem to love it. We have the closed feedback loop that shows that these actually work. So we know that if you worked on the action, it actually helped the network. The counterfactual, you didn't work on the action, it actually hurt the network. So we have that. Now we are going to convert that into actual actions that the system will do using an agentic framework, which also now, luckily for us, the technology is there. So this is where we are headed. So long story short, because we had a cold start problem at scale, so we started with Composite AI. We started with traditional machine learning to root cause analysis and using Gen AI to represent the information. Now we are building Gen AI itself into part of the reasoning. So it's an ensemble now of systems getting more and more accurate. And then the insights that we have, we're going to now action them next year through an agentic framework.
That was pretty amazing at Amazon scale, by the way. And for each of us, I'm sure we are all Amazon.com shoppers. Getting our stuff on time is very crucial. So Shiva, could you also just tell us a little bit more on the business, not the tech side of it, but the people process side of it? Because achieving alignment on what are you going to go after, even as a business problem at Amazon scale, can be pretty tough. How did you go about it, and how did you get alignment on what are you going to do?
Yeah. So through a combination of tech and process. So the classic silo problem was always there. You have so many teams, all best intentions, building the next data lake, building the next, and the greatest metadata catalog, the one catalog to solve it all.
That's right.
And you see that, on Redux. But luckily, we were one of the lighthouse customers for SageMaker Lakehouse. So we were able to get on this platform where you could now, with zero ETL, now you have the just one metadata catalog, which helps you with two things. One is discoverability, so you can semantically search for all kinds of assets, whether they are data assets, metric assets, feature engineered assets. So you have these machine learning, features. You can search for those, and also dashboards that you've built. And prune out the ones which are not being used, prune out the ones which are redundant, and so help create this single source of truth for all of Amazon. And the other thing that we are doing is this now gives us lineage. This is very crucial when you're dealing with a system like Amazon, where there are multiple hops in the whole network. Understanding lineage and where things break is also important. So luckily, with, again, a plug for SageMaker Lakehouse, with that technology, we were able to stitch everything together so that we don't need to do one more migration, one more data lake. That's a good thing. The other thing we did is purely process and governance, which is let's look at which teams have all the network level metrics that they manage. So cross-network, and that's like the network hub. And then they manage and they are responsible for the things which drive action at the network level. And then we have domain hubs. They're responsible for their domain. They're responsible for deeper dives into issues. So for example, whether it's last mile or whether it is the fulfillment center and so on. And the way we do the governance is, in Amazon, everything it's all about mechanisms, right? So there are mechanisms about which teams are responsible for which areas, and then they basically own the single source, the source of truth. And then the other teams which are responsible for something else, they own that. And then we have a system of guardrails. If you play in that sandbox, these are the rules you have to follow, and these are the permissions you need to set, and so on. Again, one more advantage is now with actually having single sign-on capability across all these different systems. You're able to manage permissions, etc. So you're able to track not just intent, but also through technology, you're able to enforce those guardrails. So through a judicious combination of process as well as technology, Shikha is what we have used, and it's still ongoing as we speak.
Yeah.
Yeah.
Yeah, it's not a problem that gets solved. It's like something you got to keep working on, like a good muscle you need to continue building. And I know at HCLS, for you guys as well, you're doing some pretty cool stuff. What do you think has worked really well for you? What would you like to share?
Yeah, I think one component that we introduced lately was really around data mesh. So if companies are growing, and we were founded in 2004, obviously then we had very small system infrastructure. Probably people were still going directly to databases, doing query and getting analytics out of it, right? And then you're getting to a point where you're growing and you're thinking, oh, I probably need an analytics platform to be able to actually manage this. And then we introduced a central way on how we're doing analytics, where we're collecting all the information, putting that into an analytics platform, and having a central team basically building dashboards or queries or reports that we're then distributing to the different business operations teams. And that works to a certain point where you're basically creating a bottleneck in the organization which is trying to fulfill all those different requests that they're getting across the business organization. And then at the same time, they also have a bottleneck in regards to accessing the data from the systems, because some of them might not structure it in a way that actually works well for reporting. Some of them might not have it in a source which really is easy to query. Or even doing ETL out of it, right? So that's where we decided a while back that we really want to change the way on how we're creating the analytics infrastructure, where we have a fully distributed way on the data side. So each system, each organization, each unit is responsible for its own data, managing, defining, and exposing that data to the organization. And they're the owner and shepherd of that data. They know their system best. They know how the data should be structured. They know when they do analysis what additional things they need to add to be able to have a great data product that they're actually exposing. At the same time, if you're doing this, obviously now you have some other challenges. One is security and access. One is being able to actually explore the data or figuring out what data is available in the organization. So that's when we worked with AWS and really were able to leverage DataZone to create the centralized governance where we have the ability to create all data products in the catalog, being able to have the users to explore what data is available, request access to the data, even have fine-grained attribute level access as well. So specifically in our area, obviously PHI and healthcare information is very restricted. So you might have access to certain aspects of the data, but you will basically blind it out for all the PHI. So those things enabled us to really create a coherent data strategy where every single system is responsible to expose the data products to the organization. We have, so this is very distributed, but then a centralized catalog and access model with corresponding security. It also allows us to really control the data because now it's centralized in that catalog and we know who has access to what, and it's not copied over in many, many different places where we then can't really trace anymore where that data is going. So I think that helped us quite a bit to be able to have a coherent approach here.
And that's very similar to, Zach, what you and Shiva have been at it too.
Yeah, I mean, it's interesting everybody's kind of mentioned slightly different aspects of the same thing.
Right.
But I think we're in the same process of going from centralized control over data, which is frankly a bottleneck, inhibits discovery, all of these things, to a much more distributed system of mesh. But actually, I think, we think about mesh because of the technology that we have involved in it, but actually it's data product ownership, where it should be appropriate. Doesn't frankly matter the tech that we use to put it together, but in the old world, because of the tech, people would go write ETL jobs, and then the consumers owned the whole pipeline from the source to the end with no contract, with very difficult to change, very difficult to manage. And I think this shift towards data products and ownership outside is actually really critical. So.
Yeah. Does that resonate with folks here? The distributed versus centralized? Yeah? Sounds very familiar. Cool. All right. I think, Zach, you guys have done some pretty cool stuff with your governance strategy. Do you want to talk a little bit and share what you're doing with generative AI governance?
I think there's a couple aspects. So we generally have a view that the best, in a bank, we're very regulated, similar to you guys. And we only are allowed to use our data for particular purposes. We have to do privacy impact assessments. We have to do, manage all of our GDPR compliance, but also all of our regulatory compliance around models and model risk. And so there's a lot of steps. And I would say traditionally, the governance steps were mostly done through meetings. So if you want to build a new model, you have to go sit in front of 12 people and explain to them why you want to build the model and what your method is, and then come back once you've built it and have them approve it, which is really just ridiculous in terms of time, frankly. It would take you longer in governance than it is you look at all the announcements that we had on stage this week. Most of those were things that were developed in the last 6 months. In 2020, when I got to the bank, it took us 2 years to put a model from idea into production. You think about how fast the tech is moving. By the time you're done, you'd have a whole new tech stack around available to you. So it just didn't make sense. So we've really taken this strategy that we want to embed all of our governance, all of our controls right inside of the pipelines to either build a model, access the data, do a project. And DataZone and what we call our marketplace has really been critical to that. So if you're going to start a project, the attributes of that project then drive the governance that we have and that's built into the actual deployment that we have and into the pipeline. So if you're going to build a model, then you'll have all the model governance controls built into that pipeline as a data scientist, and you do those. And we do risk assessments dynamically, so if it's a low risk, then you just rock on. If it's a high risk, then you might have to go talk to some people about it. Or if you're using a pattern that's not a pattern that's a normal pattern for us, you might have to go talk to some people about it. Kind of nicely pushes people to use the good patterns because they get their work done faster. Nothing motivates an engineering or a data scientist that they can do stuff faster. If you put a little friction, sometimes that's good. But even just an analytics project, we have to file a PIA to make sure that we can access that data for that project and that we're doing it in an appropriate and ethical way and putting that into our data marketplace. So you talked about discoverability, that's one barrier. You talked about the access controls, and that's critical for us. Separation of front office and back office, for example, is part of our regulatory controls. But then on top of that, why are you using the data? Is this a legitimate use? Is it inside of our GDPR compliance and policy? And we try to put all of those inside of the pipelines, inside the tech that you actually are doing that. And it's we're not all the way there. Some things are still a little kludgy, but I think what we're finding is that speeds up our path from an idea to actually value being created. It also actually makes our governance better, makes the compliance better, requires less people to govern, less meetings. It's this really virtuous cycle if we can put it all into the pipelines themselves as opposed to doing that. And I think with DataZone, we've really been able to take the project idea and then start to build our governance around that and into it as part of the way that our developers or analysts or data scientists actually use the data, and or build a model or build any of the kinds of projects that they're doing, we can build those together, which is pretty cool.
Yeah. What I really like about what you guys have done is that you're really embedding governance in the workflow.
Yeah.
So it's not a tax outside that you have to think of, and I think all three of you spoke about that in different ways, and that's really cool because then it's not an extra meeting or an extra.
Yeah, well, and that's the reality is basically what it does is mean that I have to go to less meetings, which is really my goal. So if developers want to do things faster, I just want to go to less meetings. So.
Yeah. No, that's very, very cool. All right. I think one thing I wanted to get out of all of you is you guys have done tremendously great on your journeys and are embarking on some very cool generative AI initiatives. What is the one piece of advice that you would give to somebody who's getting started or maybe in the process and dealing with all the challenges that you have dealt with? If you were to pick one thing, Shiva, why don't we start with you? What would that be?
Sure. Start with the right problem. I was in this AWS Finance Summit, and I was invited to that by John Felton. He used to be in operations, and he now moved back to finance, because we were one of the few teams that actually went to production. So in startups, they call it product market fit, right? So start with a problem that is really a problem to somebody. And then, it just so happens that Gen AI is a means to solve it, or some kind of machine learning or whatever. But start with a problem, and I think there are two broad mechanisms. In Amazon, we look at everything through mechanisms. So the first is an incubation mechanism, and the second is the operationalization mechanism. So incubation, if you have an idea, talk to the folks in the trenches, see if it actually has legs. If you build it, would they use it? Then do a quick science experiment, make sure it works, do a small rollout, see if it actually proves the concept, and then focus on operationalizing the solution. And by the time you have operationalized the solution, you need to have 5 things in place. The first, you need to have the data platform in place. You need to have the feature engineering in place. What features is your model using? So you need to have that in place. You need to have the model pipeline in place. You need to have the model build pipeline. You need to have the model vending pipeline. How are you going to share the model results? And you also need to have model management and something to audit the model, because as all of us know, these models atrophy with time as data changes, so you need to be able to look at that and refresh the models, if you will. So A, start with the right problem, and B, be very cognizant that you need incubation and the ability to operationalize and scale. You need both those capabilities to be successful. Thanks.
Thank you, Shiva. And I think, Mirko, you had mentioned culture change is a big deal for you guys.
Yeah, so I think specifically when you're shifting kind of like from a centralized model where you have one team focusing on preparing the data for the whole organization to a fully distributed one where now each of the components or applications or teams are responsible for the data, culture change is kind of like a big piece that you need to make sure is actually happening as well. I mean, I think you mentioned the chief data officer stays in there for like 2 years, right? I think that's kind of like a good indicator that probably the culture didn't shift when the chief data officer was actually appointed.
That's right.
And the whole organization was just waiting till the CDO was doing something, right?
Yeah.
It's not, I mean, the CDO is obviously driving this, but the whole organization needs to come with it on that journey to change the way on how the organization is using and managing data. And in our case, that was the same thing. We had now in teams which had to work through kind of like questions of what questions do the business actually ask for their systems, right? What is relevant? What do we want to expose? What should those data products be? How should we actually manage them? If we're adding new features or functions, what is the data implication on it as well, right? Are there new models that we need to expose? Are there things that we need to change in the relationship of those models, and so on? They also now have to talk with different other organizations or parts on teams as well to make sure that the data products that they're exposing actually work well together with all the other ones that are exposed, right? So those are things where you have like to implement really a culture across the organization so that data is on top of their mind when they're implementing new functionality or new components in the organization. If you're not doing this, you're basically going to have a nice catalog which might not be filled at all, right? Or you might only have 1 or 2 products in there. The value basically goes away. So I think with the implementation, specifically if you're going distributed, I think even if it's centralized, being able to actually change the culture in the organization and being able to put data up on the priority list is a big component.
Thank you, Mirko. And Zach.
Yeah, I think one of the things as we've put more generative AI models into production, at the kind of wrap up of each of those, the one thing that I hear from almost all of my teams is, oh, if I'd started this project now, I'd do it differently. Because the tech's evolved, the learning's evolved, all of those things have evolved. And those are like 5-month projects, so not that long of projects. And so we've really started to think about, actually, we kind of want to pick projects now, especially for our core, our central, like the best kind of data science teams that I have that are leading the cause, is we want to pick things that are actually seem magical, that are so far out that we really don't think they're feasible right now. And the reason that we're starting to do that is that the reality is by the time the project's done, they will be. So, we're thinking about things like voice-to-voice and image that we know actually the LLMs can't do now, but in 6 months they will probably be able to. Certainly in 8 months they'll be able to. And if by chance we finish the project and it fails because we can't quite do that yet, we just then come back and pick it up again. We've built all the application usually, the data, the RAG infrastructure, whatever the data set is that we're using to drive it. And you can just come back and say, all right, now we've got a new set of models that have new capabilities. We'll plug them in and see if it works. And we've done that a couple times, and it's really shocking for me to say like, oh, we did a project that usually, certainly in a bank, we think like, oh, we want to like be things that are innovative but feasible. When you start, you don't want to set off on a journey you're going to fail. And so we're really having to shift and be bold and think about things that feel magical, because by the time you get there, they're possible. And if you start the project just thinking about what's possible now, you actually kind of underbuild and underwhelm, and have to go back and redo it again anyway. So it's better to start with the magical, and pull it back a little bit if you have to, or revisit it again in another 3 or 4 months. And so I just encourage our teams to really be bold on what they think, like go beyond what they know to be possible now, in terms of the solutions that they're designing and what they're selling to the businesses, and what the business, really encouraging the businesses to give us their hardest business problems, that we don't really think is plausible now, but we incorporate them into our projects. And it's been shocking how good that is in terms of what we can do and how big the impacts are. And so I'd say I just encourage everybody to be really bold in the capabilities that you're doing, because you look at the capabilities, like we just went live with our graph embeddings model, and you see what Swami announced this morning with GraphRag in Bedrock. Like, we'll rebuild that now with those capabilities. If we did that now, we'll make that model better, but that's because we already have all the data there. We'll just take those capabilities and redo it again. And I think those are like really great learnings and great capabilities for us as a business. So.
Yeah, that's a great advice to wrap up the session, I think. With the pace of innovation that we are seeing right now, magical is possible.
Yeah.
And so I really love that. Okay, cool. Well, thank you very much. I think we are at time. Thank you, panelists, for being here and sharing your learnings. And thank you guys for coming here and participating in the conversation.